नमस्ते दोस्तों। मेरा नाम है पंकज सालुंखे और आप देख रहे हैं मेरा नया यूट्यूब चैनल एरोस्पेस गेट एकेडमी। Okay दोस्तों, a lot of guys are interested in doing the GATE in Aerospace Engineering 2019. So मेरा वीडियो बनाने का जो मेन मकसद है वो है जो हेल्पिंग आउट द students who are preparing for the 2019 exam. Okay, so most of the people know what are the syllabus for the GATE exam for 2019. So today we are going to learn about the main one topic from the aircraft performance, like flight mechanics, like atmosphere. So okay, this is the most important topic. Okay, atmosphere. So what is the atmosphere? Atmosphere is nothing but it is the mass of the air that surround the earth's surface. Okay, that mass of air is called atmosphere. Okay, this is the simple definition of the atmosphere. Atmosphere क्या है? Atmosphere क्या, जो mass of air है around the earth, this is called the atmosphere. Okay, hi guys, now we are going to see the what is the layer of atmosphere. And this is you are seeing this diagram. This is the height of the temperature diagram, and in this diagram we are going to see the different layer of the atmosphere. So as we know that the standard sea level temperature is always 15.2 degrees Celsius, and we can convert into Kelvin by the adding 273 Kelvin. So 273, so it can be converted into Kelvin. So first you can, this is the zero height, mean this is the sea level condition. This temperature is 288.16 Kelvin, means we just added 273 into the 15.6 Kelvin. So that sea level temperature will be 288.16 Kelvin. So there are different layers. First layer is troposphere. So troposphere is situated from 0 to 11 kilometer of the height. Okay, so this is already seen, we have already seen the what is the lapse rate. Lapse is nothing but the decreasing the temperature or increasing the temperature per unit per kilometer. Okay, so here we can see the this is the increasing from this point, because this is increasing the temperature and this is the decreasing the temperature. This line decreasing, this is increasing. So we are seeing this as increase the height at the 11 kilometer, the temperature is decreased up to the 216.16 Kelvin. This is called the troposphere. Okay, most of the aircraft fly to the troposphere. Okay, most of the aircrafts. Okay, this is the troposphere, and lapse rate will be 6.5 Kelvin uh, per kilometer. It means that the temperature decreases 6.5 Kelvin per kilometer in this region. This is called troposphere. This is the first one. Now this second is the tropopause. Tropopause means temperature will not change or in other way we can see the say that the lapse rate will be 0, temperature will be constant. So 11 to 25, this region is called tropopause. Okay, it's tropopause. So temperature will be constant here. So to 16.16 to 16.66 Kelvin will be same temperature up to the 25 kilometer. So from the next will be stratosphere. From this region, stratosphere is from 25 kilometer to 47 kilometer here, we can see that. So it's called a stratosphere. And this middle of the stratosphere we can see the ozone layer is it's situated around a height of 28 kilometer. Okay, this is called, and the lapse rate of you can say that this positive lapse rate means temperature again increasing from the 25 to 47 kilometer. So temperature from increase to 16 to 16 Kelvin to 288.16 Kelvin. Its lapse rate around to 4.5 Kelvin. Okay, so next is the tropopause. Pause, this means particular means temperature is constant. In the statopause, what is the 47, the region is 47 to 53 kilometers, only 6 kilometer region statova, there is the temperature is a constant. So temperature is a constant 88 to 88.16 Kelvin. Okay, next is mesosphere. Mesosphere region is a 53 kilometer to 79 kilometer, 79 kilometer. Okay, so its temperature again decreasing. Okay, lapse rate is negative. So temperature from decrease from 80 to 82.16 Kelvin to the 165 to 66 Kelvin. Okay, so it's region around a 53 kilometer to 79 kilometer. Okay, and lapse rate around the minus 3 Kelvin per kilometer. Okay, and second will be mesosphere. Mesosphere is around the 79 kilometer to 90 kilometer. It's around the 28 kilometer region, so it's called a mesopause. Okay, so again next is the thermosphere, 90 kilometer to the it's from the 500 kilometer like ionosphere. Okay, there's a the difference other spheres but mostly important for aerospace get particularly for the aerospace area, this stratospheres, tropospause, and this tropopause troposphere, tropopause, stratosphere and stratopause is very important up to 53 kilometer. Okay, ozone, and this most important thing, ozone layer situated 28 kilometer at the 28 kilometer. Okay, and important thing is the point here, this point here why we studying this. So we in the exam we have to calculate they will give in the exam, they will give the particular height and we have to find out the temperature, pressure and the density that particular height. So that form that we have to calculate in the exam, so this is very important. Okay, so the first important property is the temperature. So what is temperature? Temperature is nothing but the kinetic energy of the molecules. So sea level, the standard sea level temperature is 15.2 degrees Celsius, remember. So to convert into Kelvin, so 15.2 plus 273 is around 288.2 Kelvin. This will be the standard sea level, sea level of the temperature. So this is the standard temperature. So next is next is generated by the T. So next property is pressure. Okay, is generated by the P. Okay, and definition of the pressure is the force exerted, the force exerted by the air. The force exerted, ये atmosphere है, the force exerted by the air on the surface or the some object of the object of the, is called the pressure. Okay, pressure, it's actually sea level pressure. Sea level pressure is generally 1 bar. Sea level pressure, okay, sorry, सी लेवल का प्रेशर होता है 1 बार, विच इज इक्वल टू 10⁵ न्यूटन पर मीटर स्क्वायर. ओके, दिस इज द एसआई यूनिट ऑफ द प्रेशर. ओके, थर्ड है, थर्ड मेन इंपॉर्टेंट प्रॉपर्टी है डेंसिटी. Okay, density is denoted by the rho. Okay, is denoted by the, what is the density? Density is the amount of molecules, okay, amount of molecule per unit meter cube, in meter, one unit meter cube. So density, so sea level density, standard density is 1.225 kg पर मीटर क्यूब. इसका मतलब है आप सी लेवल पे जाओगे, एक क्यूब लोगे, ठीक है, एक क्यूब लोगे, उसमें एक क्यूब है, मतलब एक क्यूब है, इसका हाइट लेंथ ब्रेड सब 1 है. अब इसमें आप जाके हवा कैद करेंगे, you catch the air from the sea level, then its weight will be exactly equal to 1.225 kg per meter cube. ठीक है, this is the density. Okay, so next property, is fourth property, viscosity. Okay, actually there are two types of viscosities. Okay, a viscosity is nothing but a resistance to friction. ठीक है, so by the Newton law you know that this is the tau is proportional to du by dy. Okay, so tau is equal to mu du by dy. This will be the viscosity. This is the shear stress. Okay, this is the velocity gradient, and this is the viscosity. So the actually viscosity are the two types. One is dynamic viscosity and second is kinematic viscosity. It is denoted by mu and it is denoted by the gamma. Okay, so these are the important properties for the standard sea level. Okay, now we are going to discuss the types of altitude. Types of altitude. Okay, so first type is geometric altitude. Geometric altitude. Okay, is called Hg. Okay, actually what is geometric altitude is, this altitude is measured from the surface of the earth. It is measured from surface of earth. Okay, this is the geometric altitude. Second one is absolute altitude. Absolute altitude denoted by HA. It is measured from center of the earth. Okay, and third one is most important, geopotential altitude. Okay, denoted by H. Okay, these are the three main types of the altitude, and now we are going and this altitude is also measured from surface of the earth. Okay, now you are thinking what is the difference between geometric and a geopotential altitude. Okay, this is a different, this is measured from the center of the earth, but what is different between geometric and geopotential? Okay, there's different actually. So we are going to see what is different with geometric and geopotential. So when we know that this is earth. Okay, and as we going up from the earth, what happened, the gravity will be getting weaker and weaker and weaker. So consider here is a G. So here G will be delta G, because sorry, G minus delta G. Okay, so there will be a change in the gravity. There will be change in gravity with change in height. Okay, so if we using the geometric altitude, what happened, it altitude is measured in this case geometric altitude is measured by local G. Whatever G is available of a particular height, that the corresponding that G means gravitational, we calculate geometric altitude. But in case of second altitude, geopotential, okay, altitude, what happened, we consider G gravitational constant is gravity is the constant is equal to 9.81. so what happened, because gravity is changing but it's not that much changing, so it's not affecting that much, so we considering we reduce the complication in the calculation. We consider the gravity is the constant. That is a difference between here G is changing, okay, and here G is constant. That is the only difference with geometric and geopotential altitude. So there is a relation between the geopotential and geo altitude. Okay, so now this we denoted this is by geo and this is by G. Geometric, this local G is denoted by G, and the constant G is considered is by G. So local G is equal to geo R by R means R plus Hg square. So here is G is a local G, local gravitation. Local means for that particular height gravitational constant. So geo is the 9.81 obviously. Okay, next R will be radius radius of the earth, radius of the earth, and next is hg, obviously geometric altitude, metric altitude. So we can calculate putting these values into g. Okay, so now we are going to see hydrostatic equation. Okay, hydrostatic equation. Okay, so you are thinking of what is the hydrostatic equation and why we using the hydrostatic equation. Hydrostatic equation used for the change in change in altitude and the change in the pressure, relation between the, we have find out the change in the pressure. Okay, so we use the for that we use the hydrostatic equation. Now how going to derive the hydrostatic equation? Now first consider this is the earth surface and this is the atmosphere, right? So we consider small element here, air element, which the okay, the length, sorry, width, length is equal to 1, and we considering this height is hg. Okay, this is height, will we consider the hg. So here is pressure, obviously there will have some pressure, here will be pressure, right? So consider here this point we considering p pressure. So after this point we consider pressure will be changed. Okay, right? So pressure will be pressure, here pressure will be pressure, this pressure plus whatever delta pressure, delta whatever pressure will be changed. Okay, from this point, so there is the this point we consider pressure p, and from certain height, after certain height there will be change in pressure due to height. So pressure changes, the p pressure will be p plus delta p, whatever plus or minus. Okay, always from this earth, this is low pressure, this is the high pressure, right? Always. Okay, as we increase the height, the pressure will be decreasing. Okay, so now calculate. Okay, so what weight, we know the weight is equal to mass into gravitational field. But what is the, we know the what this formula. So what is the density, what is the density, right? What is the density? Density is the mass per unit volume. By this formula, mass is equal to rho into volume. So okay, so put this formula in this equation. So we got W is equal to, so this formula into this. So what happened, rho into volume, we consider this constant, this is for volume, into the gravitational constant, right? So we know that volume of this cube, rho into what will be the volume, one high, what will be called length, breadth into height. So what is the length will be 1, breadth also 1, and height will hg into gravitational constant, right? So W will be rho h g g. So weight of this element will be this. This is equation number 1. So now calculate now from this to this. Okay, now what is the this we find this equation 1 for the weight, rho into h into g. So GHG is the geometric altitude. So now what is the weight of this element is different. See, consider this is point and this is point, and weight is nothing but whatever the difference between these two pressures, right? So one pressure is acting on this side and the second is acting on this. Whatever is difference of two pressure is the weight, right? So this is the more pressure, so we adding this pressure, oh sorry, subtracting the pressure minus P plus delta P, right, is equal to weight of the element, right? So P minus P plus delta P is equal to, what is the weight? Rho H G into G, right? So this will be minus delta P is equal to rho H G G. P will be cancelled, so answer will be minus dp minus delta P rho H G G. This will be second equation. Okay, this is the first equation, this is the second equation. Okay. At the sea level, we can see that, okay, at the sea level, okay, this is the for anytime we can use, but for the sea level geo potential altitude, we can find the same formula. Okay, what we can use for geometrical altitude, geo potential altitude at sea level, okay, minus dp rho uh, rho g delta h. Okay, only difference between this is delta h, or this will be this will be h, right? This is only different. Okay, so now we are going to now we are going to divide. This is the third equation. Okay, now we are going to divide these two equations. Okay, we are going to divide equation 2 by equation 3 by equation 2. Okay, so what is equation number 2? Minus dp is equal to rho g, okay, rho g h g divided by of equation delta p is equal to rho g, sorry, this is the geo h delta h. Okay, we have put wrong here, there should be go here, right? So changing pressure equal rho go delta h. Okay, now our next procedure is, okay, next procedure we are dividing. This will be 1, this will be cancel g by go, and only remain here, we remain hg and delta h. Okay, now we are finding for the delta h. So delta h is equal to g by go h g. So now we are going to derive this equation, sorry, integrate this equation. So integrate both sides. Okay, so after integrating this, we got h is equal to r hg plus r plus hg. Okay, integration is not very important because we do not need integration, because it's very lengthy, so I just shorten and give the direct answer. So high H is equal to R Hg plus R plus Hg. Okay, this is the I this H is the geopotential altitudes. Okay, for we can find the geo, this is geo means we, if we know Hg is the geometric altitude and H is the geo potential altitude. So if we know the geometric altitude and the earth radius is 6,000, 6,000 around the 6,000 6,378 kilometer. Okay, is around radius. So we can put here, so we can calculate the geopotential. This is the very important relation between this between the geopotential and geometric altitude. Okay, so earth radius R is equal to 6,378 kilometer. Okay, radius. Okay, so important thing is just geometric altitude or geopotential at the sea level. Okay, at the both are same. Okay, because gravity also same, so both for the geometrical and geopotential altitude always same. And generally we use the geopotential altitude for general use, because it's easier to calculate the altitude when the gravitational is constant. Okay, so we use a geopotential altitude always. Okay guys, next topic, next thing is we have to find uh, change pressure, density and temperature with respect to the changing height. Okay, this is very important question. The gate exam, they always ask the change in calculate the pressure, density, temperature at the certain height. So these are the very important. Now we are going to derive this, that the equation. Okay, so now we already know that dp minus dp is equal to rho g delta h. Okay, that is equation number 3. Okay, so and p is equal to rho rt. Okay, this is the general equation, and so we are going to divide by this equation. So what will be the answer? This is dp by p. This minus will take here, rho will cancel, so only sorry, this is the ro, sorry, it's for, because we are calculating for the geopotential altitude. Okay, geopotential, so this will be geo, so rho will be cancelled, so remaining the go by rt and delta h. Okay, understand? We dividing this equation by this equation, p by rho rt. This is the physics general equation, so we dividing, so minus, we take the minus this side, so dp by p, rho cancel, go by rt delta h. Now we integrating the both side. Okay, so always and understand, so p1, t1, rho 1 are base values or reference values. Reference values means this we are taking means this is the some changing the temperature. So this point will be P1 or this point will be P. We know these values, this should take as a P1, as unknown only P will be P. Okay, this will be reference values. Okay, so we derive integrating dp by p is equal to minus integrating go by rt delta h. So we putting the limits. What is the limits? Limits are we are integrating dp by b from p1 to p. So putting p to p1, okay, from this value to this value, and in this case same h1 to h, because this is h, this is dp, whatever changing, that is the limit should be there. Okay, so in after integrating, we know that this is the this answer is log p, limit from p1 to p is equal to go rt is constant and delta h will be h1 and h. Okay, so putting the values, so log p minus log p1 is log or ln, okay, go by rt h minus h. We know that putting the limit in the, we have to first this take, we have to put this value first and second this value, and we have to minus it. So ln p1 is nothing but we can convert into p by p1 is equal to go by rt, this is the minus, and h minus h1. So we get here equation is, final equation ln p1 is equal to minus go by rt h minus h1. So taking the ln this side, so p by p1 is equal to, is going into e raised to minus go by rt h minus h1. Okay, this will be the equation, and also this is same for the row by row 1. Okay, this is so important. This is the use for the only we can use this for the troposphere. This is used in troposphere and stratosphere. Okay, for we means in this case this is the reference value, this is the value. Okay, go mean 9.81, r is 287, is the temperature. Okay, and it is the temperature. H is equal to h means height. Okay, changing height. Actually this is used for tropopods and this stratopod. In pods condition we using this guy. Okay, this is wrong. Tropopods and stratopods. Okay, because temperature is only one value, so this is constant value you have to put in this equation. Okay, so we can calculate any type tropopause and stratopause pressure density equation from this equation. Okay, and this is very important equation for the aerospace gate. Okay, so this is we found the equation for the tropopause and stratopause. Okay, but other for a stratosphere and for the changing temperature we had to find out. So we know the first equation, general equation, dp by d is equal to minus go by rt delta h. This is a general equation first. Okay, so we first what is we already discussed lapse rate. Lapse is nothing but change in the temperature with respect to height. Okay, we denoted by the a. Okay, so we have to put the about delta, so we can convert into, okay, Manu. So delta h is equal to delta t by e. Okay, understand? So we are putting this delta h into this equation. So delta p by p is equal to go by rt, so dt by a. So simplifying the equation, so this is dt, this is t, so minus go by ra remaining delta t by t, which is equal to d by p. Okay, this is simple simplifying. Now we are going to integrate again both sides. So integration will be same, what, ln p, we are putting the limit same, p1 to p. Now here t1 to t. So here here we are going to the integration of dp by p is the p. So values are p1 is equal to minus go by ra t, and okay, this is the again ln t, and values are t1 to t. So simplifying, okay, ln p by p1, because when put p it will be ln p minus ln p1, so is again come to the this stage ln p. So minus go by ra, putting t ln t plus minus ln t minus 1, so it will be again ln t minus t1. Okay, ln t minus t1. So we can cancel the ln both side. We can cancel this ln and this ln. We can cancel this ln and this ln both side. Okay, and remaining we can remain this remain only p by p1 is equal to go by ra. Okay, go by ra, go by ra. And before the cancelling we have to understand, we cancel here is the array, so we can take ln p1 ln t by t1, so we can have to raise to go by ra. So now we can cancel ln, so remaining only p by p1 is equal to, now cancelled, so only remained t by t1, okay, minus go by ra, raised to minus go by ra. Here is the p is a reference value, p is a pressure, t is the temperature, reference temperature, minus go means 9.81 287, and this is a lapse rate, whatever lapse rate is it. We know that lapse rate is always in stratosphere and troposphere. Okay, so this value is always for the stratosphere sorry, troposphere and stratosphere. Okay. Okay, so now going to next is density. For density is easy. Okay, we have to just add. So we know that P is equal to rho R T. Okay, so R is constant, so we can say that, okay, we can say that P by P1, okay, is equal to rho by rho 1 and into T by T1, because it is proportional to each other, we can say that. So we if we need, okay, if we need rho by rho 1 from this equation, we need just have to add okay, so we need rho by rho 1, so we have to P by P1 multiply by T1 by T. So already we found out the P by P1, so T1 by T we have to multiply. After multiplying the by the T1 by T, okay, we just got the answer. Simply rho by rho 1 is equal to T by T1, okay, GO by RA plus 1, bracket complete. Okay, this is the use for the this is we use for the finding the density for in the stratosphere and the troposphere. Okay. Okay, now we have discussed all about the atmosphere, and now the problems. There is open sheet. Problems. The first problem, find out pressure, density and temperature at 8 kilometer. Okay, so we know that the sea level condition, answer sea level, okay, conditions. Always this remember this sea level condition. So these are the reference values. So this this is the height versus altitude diagram. So this is the decreasing temperature. This is the 8 kilometer. Okay, this is sea level. This is the 8 kilometer. This is the kilometer 0, and this is the temperature. Okay, so temperature is the decreasing, right? So sea level condition are always reference value. P1, we already, what is P1 reference values? P1 1.0 what is 1.01325 into 10 raised to 5 Newton per meter square. This is the standard sea level value. Now the density rho 1 is 1.225 kg per meter cube. Temperature is always 288.15 Kelvin. Okay, this is the standard reference values for the calculating. We know this is in this region come into the troposphere, so we use the formula for the troposphere. Okay, what is the formula for that? The formula for the formula for the stratosphere, troposphere is for this particular, for when is temperature not constant, we use the formula rho by rho 1 is equal to P by P1 is equal to E raised to minus GO by RA. Okay, H minus H1. Okay, complete. Okay, so we know the rho 1, we know the rho 1 p1. This is the in can find out calci. This is R 287. Okay, R is 287 is gas constant. Geo is the 9.81. Okay, and this is what is the difference between height is 8 kilometer. Okay, h minus h1 is equal to 8 kilometer. Okay, this is 8,000 meter. Okay, and A is lapse rate. What is the lapse rate for the 6.5 Kelvin per kilometer, or minus 6.5 10 raised to minus 3 Kelvin per meter. Okay, but we have to everything use in the meter, so we put this value in A. Okay, this is the lapse rate, so we putting this value. We're going to put, so P, we have to find P is the pressure at the 8 kilometer by reference value 1.01325 into 10 raised to 5 is equal to E raised to minus Geo means 9.81, R is 287 into A is minus 6.5 10 raised to 3, and H is equal to 8,000. Okay, so P will be, okay guys, we were finding the pressure. Actually with this formula is little bit different. We don't have to use this one, this that is the tropopause. So only Geo by RA formula is the is completely different. Actually I have put the wrong formula here. So formula is, sorry for this, P by P1 already given exactly same, but I written wrong here, so wrote the wrong there. P by P1, T by T1, and Geo minus Geo by RA. So we can put these values and calculate the answer. So what formula is P by P1, T by T1, Geo by RA minus T. So we know the P1, T1, and we can calculate the T. How we calculate the T? T will be 288.15 because sea level into minus 8 into 6.5 Kelvin, because say the temperature decreasing 6.5 Kelvin per kilometer. So we can calculate this. So answer will be temperature will be at the at 8 kilometer will be 236.15 Kelvin. Okay, so we got the temperature. We know the value Geo, R value 280, R A is value 6.5 Kelvin. So put this formula, P, what will be P1? P1 will be 1.0325 into 10 raised to 5 is equal to, temperature is 236.15 divided by 288.15. T1 is reference value minus Geo, what will be Geo 9.81 by R is 287 into minus 6.5 into 10 raised to minus 3. So we have to put the values in the formula and calculate the P value for pressure at the 8 kilometer. Okay guys, so pressure is around 0.35 bar or 0.35 into 10 raised to 5. Okay, Newton per meter square. So we got the pressure here. Now we are going to calculate the density. So density, for the density is the not different, that much different. So different, we just have to add this one. So rho by rho 1 is equal to T by T1
minus GO by RA plus 1. Okay, so this minus sign is out of this bracket. So we know the don't know the row, though this reference value will be 1.225. This temperature is 236.15, 288.15 minus 0, same values all above. So density will be, 0.5248 kg per meter cube. Okay, this is the density. So we can easily calculate the pressure density. So this we are used find for the stratosphere, or this way this is the stratosphere or the troposphere. Okay, and now we are going to find for the in pause conditions, like tropopause and stratopause. This equation we are putting the same, and with some now second problem. In troposphere from 11 kilometer to 25 kilometer, right? So we are going to find for maybe 16 kilometer, find temperature, pressure and density, right? Okay, because in the pause condition. So these are the 11 kilometers, so we are going to find, so reference value will be here, will be different. Okay, so here it's a little bit diagram. So these are the reference values. The reference value you have to take from, this is 11 kilometer reference value. So at the 11 kilometers you should know the values for the density, pressure and everything. Maybe sometime they given in exam they given the at the 11 kilometer the values. Okay, so now we know the 11 kilometer values. T temperature at the 11 kilometer. Okay, temperature at the 11 to 16.16 Kelvin. Okay, pressure is around, sorry, pressure is around. Okay, at the 11 kilometer pressure will be 2.23 into 10 raised to 4 Newton per meter square, and density is the 0.36 kg per meter cube. This is the reference values. Okay, so we have to put the same reference this for, we know the formula for the in this condition, because for the tropo, this is the tropopause condition. So temperature will be only T. Okay, there will be not T1 minus T, because temperature is always constant in this region. Okay, so you already got the temperature, because T is equal to T1 in this region. So we got the T value. So T is equal to 16.16, because temperature is constant in the region. Now we are going to find out the pressure and the density. Okay, tropos pause and stratopause formula is very simple. Same for the rho 1 and P1 is equal to E minus GO by RT H minus H1, whatever difference from the particular height. So we are putting this value. We know the rho 1, P1, E. Okay, E. So what is the E actually? This is the scientific calculator, right? So we have this, we can see this yellow color. This yellow color we have to use. Okay, so we putting GO is 9.81, R is 287, temperature is 216, right? So height is 8, height is actually 11 minus 16, 16 minus 11 kilometer. H1 is standard value, right? H1 11, so it will be 5 kilometer. So 5 means 5000 meter. So put h minus h1 is 5000 meter, because this and this is the 16, this is 11, so difference is 5000 meter. So putting this value, you can calculate rho and p1 values easily. Okay guys, this is the enough for today. We can you can now calculate the value different. You can understand now what is atmosphere, different layers of atmosphere. Okay, and different layers of atmosphere, and how to calculate density, pressure is at a different altitude. Okay, thank you guys.